A woman with 300 million followers asks a question. Not about fashion, not about beauty, about something 14 billion kilometers away, moving through the void at 70 kilometers per second. The question reaches NASA within hours. The internet explodes. Scientists scramble to respond. And for 48 hours, the entire world looks up. What would you do if you were the first person to see this? November 2025. Kim Kardashian posts a simple question to NASA's official account. Is 3I Atlas an alien craft? The tweet isn't casual. It's deliberate, calculated. Her followers, a population larger than most countries, suddenly care about an interstellar object most had never heard of. Within 6 hours, the tweet generates 4 million impressions. News outlets from Tokyo to Toronto run headlines. Television networks interrupt programming. Reddit threads spiral into thousands of comments. Twitter erupts into debates between skeptics and believers. And NASA responds, not with dismissal, not with condescension, with calm, measured science, no aliens, no threat to life on Earth. 14 words that should have ended the conversation. Instead, they ignited it. But something remarkable happens in that moment, something that reveals how fragile the line is between pop culture and scientific literacy. Millions of people who would never read an astronomy journal are suddenly asking questions. What is 3I Atlas? Where did it come from? How do we know it's not artificial? Why should we trust the answer? The celebrity question becomes a portal. Entertainment transforms into education. Attention becomes curiosity. This is unprecedented. A reality television star generates more public engagement with space science than decades of NASA press releases combined. A single tweet accomplishes what billions of dollars in science communication couldn't. It makes people care. But caring and understanding are different things. The comment section becomes a battlefield. Conspiracy theorists claim cover up. Amateur astronomers share telescope data. Science educators try to explain orbital mechanics in 280 characters. And through it all, 3I Atlas continues its journey indifferent to human attention. Comment what you think is happening, even one word. While the internet debates alien visitors, telescopes tell a different story. The MeerKAT radio telescope array in South Africa detects hydroxyl emission lines, OH molecules, evaporating from the object's surface. The Virtual Telescope project in Italy captures images showing a clear cometary tail streaming behind the nucleus. Spectroscopy reveals water vapor, carbon monoxide, organic compounds. Every measurement points to the same conclusion. 3I Atlas is behaving exactly like comets born in our own solar system. It accelerates, but not because of hidden thrusters, because sunlight heats its icy surface, creating jets of gas that push it forward like a natural rocket engine. The physics is called the Yarkovsky effect. It's been understood for over a century. It emits radio signals, but not messages. Molecular absorption lines the fingerprint of chemistry, not technology. When molecules spin and vibrate, they absorb specific radio frequencies. It's as natural as water freezing. Its nucleus remains intact, not exploded, not fragmenting, just sublimating the way ice becomes vapor without melting. Astronomers measure its rotation, 17 hours per revolution. Consistent with a natural body tumbling through space, they measure its brightness. It dims and brightens as different surfaces rotate toward observers. No artificial object would be so irregular. They measure its composition. The spectrum matches known ices: water, methane, ammonia, carbon dioxide, the building blocks of planetary systems everywhere. The data is consistent. The physics is understood. The mystery, in scientific terms, is solved. But here's what makes this moment historically significant. The reality is more impressive than the speculation. We are witnessing an object that traveled between stars through the vast emptiness where temperatures hover 3 degrees above absolute zero, carrying pristine chemistry from another solar system's birth. That's not less amazing than aliens. It's evidence of something equally profound. The universe operates on principles we can measure, predict, understand. We can look at light from an object never touched by human hands and know what it's made of. We can track something moving faster than anything humans have ever built and predict where it will be in 1,000 years. That's the real miracle. And yet, the public narrative splits from the scientific one. Radio signal becomes alien message on social media. Outgassing becomes propulsion system in comment sections. Acceleration becomes controlled flight in viral videos. Hydroxyl emissions become communication attempts. Every scientific term gets translated into mystery. This is the challenge of science communication in 2025. How do you sustain excitement while keeping facts intact? How do you honor curiosity without feeding misinformation? How do you compete with conspiracy theories that promise hidden truth and secret knowledge? Science offers something less dramatic but more powerful: understanding. The question is whether understanding can ever compete with wonder. A equals natural phenomenon. B equals something unknown. C equals we need new physics. Comment A, B, or C, no wrong answers. The shift happens gradually, then suddenly. Scientists grow increasingly vocal against speculation without evidence. The lesson learned from Oumuamua, the first detected interstellar object in 2017, still stings. Back then, Harvard astronomer Avi Loeb suggested the object might be artificial, a light sail, a technological remnant from another civilization. The media exploded. The public imagination soared. Book deals were signed. Documentaries were filmed. But the data never supported it. Oumuamua's acceleration matched cometary outgassing perfectly. Its tumbling matched a natural fragment. Its composition, based on limited observations, fit known physics. Every alternative explanation required more assumptions, not fewer. 3. iAtlas provides better data, more observations, clearer chemistry, longer observation window. And every measurement contradicts the technological hypothesis. Radio absorption lines appear exactly where molecular chemistry predicts. The outgassing pattern matches thermal models within measurement error. The tail structure follows gravitational dynamics. The acceleration curve fits natural sublimation. There are no anomalies, no unexplained behaviors, no gaps in the data where speculation could hide. Yet Harvard maintains its position. Loeb argues that absence of evidence isn't evidence of absence, that we should remain open to possibilities. That dismissing extraterrestrial explanations too quickly limits scientific imagination. He's technically correct about one thing. We can't prove something isn't artificial. But science doesn't operate on what might be possible. It operates on what the data actually shows. And the data shows a comet. Here's the tension. Public imagination drives funding. Wonder generates support for telescopes, missions, research programs. When people care about space, governments allocate budgets. When people stop caring, programs get canceled. Skepticism and curiosity must coexist. The question isn't whether we should speculate. The question is how we balance inspiration with integrity, how we maintain public interest without sacrificing truth. Because once trust is broken, it's nearly impossible to rebuild. And scientists are acutely aware that every exaggerated claim, every false alarm, every sensationalized headline erodes that trust a little more. Does this change how you see our place in the universe? Then, on November 12th, 2025, everything shifts, not because of aliens, because of geometry. A peer-reviewed study publishes in a major astronomical journal. The findings don't make celebrity headlines. They don't go viral on social media. They should. Earth's exposure to interstellar objects is not equal. According to researchers analyzing trajectory data from multiple interstellar visitors, incoming comets approach our planet twice as often from one specific direction, the solar apex. The solar apex is the point in space toward which our entire solar system moves as it orbits the galactic center. Think of it as the front bumper of a car driving through rain. Our solar system plows through interstellar space at roughly 230 kilometers per second. One hemisphere of Earth, the hemisphere facing that direction, effectively drives into the cosmic wind. The other hemisphere trails behind, sheltered by the planet's bulk. The statistical difference is significant, not trivial, not within error margins. Twice as likely. It means that meteor events, atmospheric phenomena, even impacts throughout Earth history might correlate with our planet's orientation toward the solar apex. It means we've been collecting interstellar debris for billions of years without knowing which pieces came from beyond our solar system and which originated here. It means that some unexplained events in our atmosphere, bright meteors with unusual trajectories, chemical anomalies in upper atmosphere samples, historical impact craters with strange isotope ratios might have origins we never considered. The researchers propose a hypothesis. If interstellar fragments rain down preferentially on one hemisphere, then geological records on that side of Earth might contain hidden evidence of galactic exchange. Ancient impact sites, unusual mineral deposits, isotope anomalies in sediment layers. We've been looking at these things as terrestrial phenomena, as products of our solar system's formation and evolution. What if some of them aren't? The study asks a question that sounds simple, but isn't. How many interstellar visitors pass by unnoticed? We detected Oumuamua by accident. A telescope designed to search for near-Earth asteroids happened to catch it leaving. We spotted 3I Atlas only because amateur astronomers in Crimea happened to be scanning that region of sky on that particular night. These objects don't announce themselves. They don't slow down. They pass through at speeds exceeding 40 kilometers per second, faster than anything humanity has ever launched. Most are dark. Many are small. Some might fragment before detection, scattering debris too small for telescopes to track. The universe, it turns out, is far more active than we thought. Our solar system isn't isolated. It's not a bubble floating in emptiness. It's part of a galactic ecosystem where matter constantly moves between star systems and Earth sits in the flow. Two narratives collide here. The celebrity tweet asks, "Is this alien technology?" The scientific study reveals, Earth sits in an interstellar crossfire we barely understand. Both questions matter. Both deserve attention. The pop culture framing generates curiosity. It brings millions of people into contact with cosmic ideas. It makes space feel relevant, immediate, urgent. The scientific investigation generates knowledge. It reveals patterns, mechanisms, truths about how the galaxy operates. And somewhere between them lies a truth we're only beginning to grasp. We live in a galaxy that constantly exchanges material between star systems. Comets ejected during planetary formation, flung out when giant planets migrate inward. Asteroids thrown out by gravitational interactions when stars pass near each other. Fragments from supernova explosions, compressed and accelerated by shock waves. Dust from dying stars, scattered by stellar winds across light years. All of it moving, all of it crossing paths, all of it carrying information. 3I Atlas isn't an anomaly. It's a messenger, not from aliens, from the galaxy itself. It carries water that might match Earth's oceans in isotope ratio, organic molecules that resemble those in our own comets, chemistry that suggests planetary systems everywhere follow similar rules. The implications cascade outward. If interstellar comets are common, then every planetary system receives regular deliveries of material from neighboring systems. Organic molecules, complex chemistry, the building blocks of life. If Earth has been collecting this material for billions of years, then some of the chemistry that led to life might have originated elsewhere. Not life itself, not organisms, but the ingredients. Panspermia used to be a fringe theory. Now it's worth serious consideration. The real question shifts. Not are they watching us, but how often do they pass by unnoticed? Not is this artificial, but what can natural objects teach us about galactic processes? Not should we be afraid, but how much don't we know about our cosmic environment? Write one sentence. This means. What happens next depends on who you ask. NASA plans enhanced tracking systems, more telescopes, better software, faster alerts. The Vera Rubin Observatory, scheduled for full operation in 2026, will detect objects like 3I Atlas months earlier, giving researchers more time to coordinate observations. The European Space Agency proposes an interstellar object intercept mission, launch a probe equipped with high-resolution cameras, spectrometers, and sample collection equipment. Rendezvous with the next visitor while it's still in our solar system. Touch it, taste it, bring pieces home. Private space companies float ideas about sample return, capture fragments with specialized nets, analyze pristine interstellar material in laboratories on Earth. Understand not just what these objects are made of, but how they formed, where they came from, what they can teach us. But funding is uncertain. Public attention is fleeting. And the universe doesn't wait for bureaucracy. Mission proposals take years to approve. Spacecraft take decades to build. By the time any of these plans become reality, dozens of interstellar objects will have passed through unobserved. Right now, somewhere beyond Neptune, another interstellar traveler might be approaching. It could arrive tomorrow. It could arrive in 20 years. It could be approaching from the solar apex right now, hidden in the glare of background stars. We won't know until it's already here. That uncertainty creates discomfort. Humans prefer predictability. We build models. We make forecasts. We like to believe we understand our environment. The cosmos doesn't cooperate. 3I Atlas appeared without warning. Astronomers had less than 2 months between detection and closest approach to coordinate observations. It will leave the same way, fading into the darkness between stars, never to be seen again. And we'll return to watching, waiting, wondering, except now, millions more people are watching with us. That might be the real legacy of a celebrity's question. Not the answer, the attention, not the data, the curiosity, not what we discovered about 3I Atlas, but what we discovered about ourselves. We still care about mysteries we can't fully solve. In an age of instant information and algorithmic certainty, there's something deeply human about confronting the unknown and admitting we don't have all the answers. 3I Atlas reminded us that the universe is stranger and more wonderful than any story we could invent. That reality, properly understood, beats fiction. That we live in a galaxy where objects from other star systems pass through our neighborhood carrying secrets from distant worlds. And that sometimes the most important questions come from unexpected places. Maybe the universe isn't silent. Maybe we just never listened. Maybe Earth's cosmic exposure isn't random. Maybe we've been collecting interstellar stories for 4.5 billion years. Maybe the next object won't be a comet. So tell me, what do you think happens next?